Hey everybody, I'm meteorologist Gavin Sandell. Although it's thousands of miles away, a climate phenomenon originating in the Pacific Ocean is one of the biggest winter weather tools in our neck of the woods. It's called ENSO, and it's short for the El Nino Southern Oscillation. It's defined as the cyclic change of eastern Pacific water temperatures. And you'd ask, how does something in the eastern Pacific Ocean change our winter weather? I'll explain all of that coming up, but the two terms that you might know from ENSO is El Nino and La Nina. El Nino meaning the increase or the above average departure of water temperatures, and La Nina meaning cooler waters, the below average departure in water temperatures. And they could best be explained by the change in trade winds coming off of the equatorial Pacific. Trade winds, those east to westerly winds, that's actually different from what we have. We have typically winds going from west to east. So you can see those trade winds blowing from South America towards Asia, but in El Ninos, these trade winds tend to be weaker or even go the opposite way, so those warmer waters kind of stagnate and there's a larger amount of time to heat up the water. So in El Ninos, you have that warm water departure from average. And in winters around here, you have changes in the jet streams. The Pacific jet stream, which you can see in red, is pushed a little bit further to the south. The polar jet stream pushed a little bit towards the north. So there's a larger gap between the two. What ends up happening in our neck of the woods, we see drier conditions and potentially warmer temperatures as well in the winter. So now the situation's flipped on its side during La Nina conditions. Trade winds, instead of being stagnant or reversed, they're actually strengthened, so they actually push that water off further to the west. And what ends up happening is the cooler waters get upwelled from South America. They go all the way from the deep water to the surface, so you actually get cooler waters ending up being cooler than average, forming your La Nina conditions. In the United States, now instead of those two jet streams being pushed further apart, you actually have them coming a little bit closer together. So that jet stream now, the Pacific one, that red one, going a little further north, the polar jet stream going a little bit further south, meaning more active weather for us, making it more wet and cooler as well for the Great Plains and portions of Canada as well. But in our area right now, we go through these cycles about every 3 to 7 years. We're in the midst of a little bit of a changeover. We're right at that fence between ENSO neutral and La Nina conditions, and some certain organizations say one thing, some certain organizations say the other. The Climate Prediction Center through the United States NOAA says we're in a La Nina condition just barely over that 0.5 degrees Celsius threshold, or 1 degree Fahrenheit threshold. This is another organization that says that we are going to be trending towards La Nina conditions. You could see in the probabilistic ENSO forecasts in the late fall stages of this year, we're going to be trending towards that area, but once we get towards winter, we're going to be more favored for a neutral pattern in our area. But in the winter time, we could see certain trends play out. Look at the coldest winters, a lot of them happening in weak El Nino years. Actually, 6 of the 10 coldest winters occurring during that time. Strong winters, or strong El Ninos, actually account for 4 of the 10 warmest winters as well. But ENSO is just one of several components to think about when forecasting the winter season. Chief Meteorologist Eric Wilhelm will be releasing his yearly winter weather forecast on Tuesday, November 11th on air, the WFMJ website, and the Storm Tracker 21 app. For Weather 101, I'm Gavin Sandell.